Okay, so in this short addendum, I'm going to go over the marginal versus the blended cost of energy. Okay, so this is really, really important to understand. A lot of folks makes this mistake out in the field. Please don't be one of those people. It's really, really important because if you use the wrong rate, you increase your chances of being inaccurate, and in this case, most likely overestimating the amount of money people are going to save. You always want to overpromise, or excuse me, underpromise and overdeliver. Underpromise, so be conservative with your estimates, and that way, you leave room for them to be even happier than you think they would be. Okay, so what is the difference here? So a blended rate takes the entire utility bill, electric or gas, divides that by the total energy use. The marginal rate takes just the energy cost, which you should have just gone over in the previous presentation, just the energy cost, and divide that by the energy use. So let's go over an example here. This is actually a commercial utility, excuse me, this is a residential energy bill, electricity bill. Obviously, there's the kilowatt hours and kilowatt down here. Got the old customer charge up there. Okay, so let's calculate the blended. The blended rate would be the total bill divided by the total energy use, right? So total bill is $108.02. Total energy use, if you add those two up, so this is your first and your last, you have 787 kilowatt hours. Okay, so you work the math out and you get 13.7 cents per kilowatt hour. So that's your blended rate, total bill divided by the total cost. What's the problem here? Well, if we're just trying to calculate the cost per kilowatt hour, but with our blended rate, we're including a customer charge, we're including a demand charge, right? So this is kilowatt, so we're including those two charges. That's not energy. Those are different. Things that you're billed for. So it's not accurate to say that you're paying 13.7 cents per kilowatt hour. So what you want to do is calculate the marginal rate. So with the marginal rate, you find the energy cost, okay, or the kilowatt hour cost, or the CCF cost if it's natural gas. So you find the energy cost, you divide that by the total energy use. So go ahead and press pause and see if you can figure it out here. So we got a per kilowatt hour charge here, 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 right? So those are all kilowatt hour, kilowatt hour, kilowatt hour, and so on. Add that all up, you get $92.81. And then our blended rate, or excuse me, our marginal rate is 92.81 divided by that 787, which gives you 11.8 cents. Okay, so the actual cost of a unit of a kilowatt hour of electricity is really 11.8 cents, because if I use they use 787 kilowatt hours. If I use 0 kilowatt hours, they're still going to get their customer charge. They'll probably still have the transmission capacity charge, because that's usually assessed once a year. The point is, this is what changes, this 11.8 cents, if you change the energy use. Okay, and you can do this for any quantity. You can do this the marginal rate, marginal demand cost, right? So if there's multiple demand costs, you can add those up and divide by the total demand for the month. You can do the marginal cost per CCF, for propane, whatever. The point is, the marginal cost is just the cost of that unit. And why is that important? Well, because it leads to error if you use the wrong rate. And here's just one small example. Let's say I replace all the lights in the building to LEDs, and I'm going to reduce my energy use by 10,000 kilowatt hours. 10,000 kilowatt hours a year, and I want to know how much money I'm going to save. Well, if I use the blended rate, say, well, yeah, you're going to save about $1,370. If you use the marginal rate, which is more accurate, it's $11.80. So that's that's a good 15. I don't know. I'm ballparking 10 to 15% more savings that you're telling them they're going to get, but they're most likely not going to get that. So remember, you want to underpromise and overdeliver. So if I tell them, yeah, you should save about $1,400 a year, but really, if my calculations are correct, it's actually going to be closer to $1,200 a year. You're overpromising, and so $200 here and there for commercial buildings generally not very significant. But if you're doing this over and over and over for these big calculations, where you're talking millions of kilowatt hours and thousands of CCFs, like, it can really add up. So that's your difference between blended and marginal use. I absolutely expect you to understand the difference. never ever use the blended rate unless I ask you to do it. So when you're in the field, you're going to use marginal use. That's the correct way to do things. Okay, so that's your blended and marginal energy cost.